The Pacific, 1943. This wasn't just a theater of war. It was a brutal proving ground where American engineering met its most humbling challenge. We sent in the P-38 Lightning, a twin-engine dual-boom marvel. It was fast. It could fly higher than almost any rival, and on paper, it was lethal. It was supposed to dominate the sky, but the paper didn't account for reality. In the close quarters, savage ballet of aerial combat, the P-38 was, tragically, a victim. The Japanese Mitsubishi Zero didn't just outperform us, it utterly humiliated us. It was a legend built on its terrifying maneuverability. It could turn inside the P-38's turning circle 3 times over. Our pilots called the Zero a ghost. The P-38, in comparison, felt like a truck. The core of the problem lay in a fatal engineering flaw that revealed itself only at the highest speeds, particularly during the critical moment of a desperate dive. Engineers called it the compressibility shock. When the P-38 pushed toward the speed of sound, a critical Mach number of uncredited, the air flowing over the wings broke down. Instead of smooth, predictable flow, the air compressed, creating a localized, violent shock wave. This shock wave transferred immense, crippling pressure directly to the control surfaces, specifically the ailerons, freezing them solid. The pilot, in a screaming dive, would yank back on the yoke, trying to turn or pull up, only to find the controls utterly useless. The plane, robbed of its ability to maneuver, became nothing more than a giant, high-speed projectile, a flying brick, a death trap, plummeting into the sea or the jungle. The high command, the aeronautical experts, they had no answer. They issued orders for new flaps. They introduced hydraulic boosters. They tried subtle changes to the wing geometry, all expensive, all utterly ineffective. The physics of the problem remained impossible to solve. The pilots were dying in droves, and the plane, a multi-million-dollar asset, was being phased out by desperation. The flaw was simply too inherent to the design. But the true genius rarely wears brass. The true battle was not being fought in the clean, comfortable boardrooms back in California, but out on the sun-baked, dust-choked airstrips of the South Pacific, the places where the only thing that mattered was survival. And sometimes, the only person who can solve an impossible engineering puzzle is a man who deals with the machine's raw guts, every day a mechanic barely old enough to shave. His name was Corporal James Reilly. He watched the planes take off and not come back. He heard the despair in the pilot debriefs. And while the PhDs saw only a complex aerodynamic failure, Reilly saw a ridiculous, tiny mechanical flaw in the control system. He saw a point where a simple, cheap piece of hardware could override the laws of physics. He didn't have $1 million budget. He had an idea, an incredibly simple yet audacious idea. He had a secret. He had a stupid idea, an incredibly stupid wire trick. The control system for the P-38's ailerons was a complex mechanical and hydraulic symphony. But when that moment of high-speed duress arrived, the elegance of the design became its fatal weakness. We must dedicate time to truly understand the relentless physics that grounded our genius. The airframe, designed by Lockheed, featured the laminar flow wing, a revolutionary concept intended to minimize drag at high altitude. This design, however, carried a terrible hidden cost. When the plane descended rapidly, pushing the envelope beyond its speed tolerance, we encountered the compressibility shock. This phenomenon, previously observed only in wind tunnels, occurred as the airflow over the wing accelerated locally to the speed of sound, creating a shock wave. This shock wave, a violent pressure disturbance, did not just reduce lift, it brutally seized the ailerons. The force exerted on those surfaces was so immense that no amount of human strength could overcome it, effectively freezing the controls. The pilot, attempting a life-saving maneuver, would find the yoke immovable. The P-38 was not stalling, it was being defeated by its own speed. This vulnerability became the Zero pilot's most reliable tactical tool, forcing a dive and watching the P-38 become an inert projectile. Our official response, adding electric dive flaps to delay the effect, was a half measure that cost millions and failed to address the root problem. But the true genius was not looking at the airflow. He was looking at the metal linkages. Corporal James Reilly understood the failure was not in the air, but in the pilot's input. The pilot, in panic, was trying to force the full range of movement against the pressure wall. The system was designed for 100% control authority, but that 100% was what led to the catastrophic lockup. Reilly's audacious insight was that if you limited the pilot's ability to input a full travel command, the pressure required to lock the controls completely might never be reached. The mod. It was an act of deliberate mechanical subtraction. Reilly didn't design a new part. He used standard, readily available materials, a section of durable 8-inch steel control cable, often found discarded. He secured this simple cable around the crucial torque tube linkage, the pivot point that translated the pilot's yoke movement to the actual aileron surface. By calculating the precise slack and tension required, he created an artificial mechanical stop. This modification restricted the maximum angular deflection of the ailerons to approximately 80% of their theoretical maximum. A 20% loss in potential travel was the price, but the gain was the retention of some control at high speed. The difference between life and oblivion. This wasn't a fix. It was a clever limitation, a bypass of a fatal design excess. When Reilly presented his crude, grease-stained sketch of the modification, a simple wire replacing a complex engineering solution, the reaction was not gratitude, but incandescent bureaucratic fury. Senior engineers, who had spent months proposing complex, multi-stage hydraulic booster kits costing thousands of dollars per plane, viewed Reilly's wire as an insult to their profession. This violates every structural integrity guideline. It invalidates the entire flight test envelope. It is unprofessional, Corporal, and frankly, it is reckless insubordination. The High Command issued a clear, uncompromising rejection. They could not, would not, admit that a simple $5 piece of scrap metal could solve the problem that their most brilliant aeronautical minds had declared insoluble. The official channels were closed, sealed by arrogance and the fear of embarrassment. But the pilots were running out of time. Facing daily losses, a secret pact formed, a genuine mutiny of necessity. Ground crews, led by Reilly's quiet certainty, began to implement the mod under the cloak of routine maintenance. The news spread through the informal grapevine radio chatter, coded messages, and whispered warnings between airbases separated by thousands of miles of ocean. Units like the 475th Fighter Group, desperate for any edge, became the early adopters of the Reilly mod. They were essentially flying experimental aircraft on official missions, risking court-martial for the chance to survive the next day. The first flights with the modified P-38 were tense, raw acts of courage. The pilot pushed the plane into a terminal velocity dive, bracing for the inevitable lockup. But this time, the controls, though heavy, responded. They were stiff, resistant, but they were not locked. The 80% restriction held the line, preventing the full range of motion that triggered the catastrophic shockwave feedback. The pilot could execute a controlled, high-G pull-up that was previously impossible. This wasn't just a fix. It was a massive tactical shift. The Zero pilots, trained for months to anticipate the P-38's high-speed clumsiness, were suddenly baffled. They initiated their textbook dive attack only to watch the P-38 execute a controlled lateral escape or a successful pullout, a maneuver that should have been physically impossible. Intelligence reports from the Japanese side confirmed the growing panic. Captured documents indicated intense confusion and suspicion. One high-level report stated, "The twin-boom fighter is now demonstrating evasive capabilities at high speed that defy our knowledge of its design limitations. We must conclude a new, significant, and hidden modification has been introduced. Our tactics must change immediately." The psychological edge, which the Japanese had enjoyed for years, evaporated overnight. Pilots who flew the modified Lightning spoke of the change with almost religious fervor. Lieutenant Davies, a veteran who had witnessed too many friends lost to the shockwave, famously stated after a successful engagement, "They chased me down from 15,000 feet. I dove, ready to die. But when I pulled back, she came with me. It wasn't pretty, but it was control. That simple wire gave me back the fight. I put rounds right through that Zero's engine block. A corporal with a piece of wire just saved the Pacific Theater." The P-38's victory-to-loss ratio began to climb sharply, a silent testament to the ingenuity of the ground crew. The High Command, unable to formally recognize the unauthorized fix, simply approved the general installation of a similar, officially sanctioned device, later the Q-model mod, or the hydraulic dive flap, but the fundamental tactical shift was already secured by Reilly's cheap, brilliant wire trick. It was a complete victory of practical wisdom over entrenched, stubborn bureaucracy. The modification was never officially sanctioned. The High Command, fearful of the political fallout and the admission of a massive, multi-million-dollar engineering failure, simply could not document the Corporal Reilly mod. There was no medal, no press conference, and no formal engineering bulletin detailing the stupid wire trick. The modification was never officially sanctioned. This refusal was the final, devastating act of the bureaucracy. The High Command, fearful of the political fallout and the admission of a massive, multi-million-dollar engineering failure, simply could not document the Corporal Reilly mod. They could not issue a memo that stated, "Our best engineers failed, but a corporal solved the problem with a piece of scrap metal." Instead, they waited. They observed the undocumented success in the Pacific and, eventually, introduced their own solution, the aileron power boost. This was the Q model mod, an official, complex, and hydraulically assisted version that, ironically and cruelly, mimicked the effect of Reilly's restriction. It was functionally the same thing. It limited the total aileron travel at high speed. But it was expensive, it was official, and it allowed the generals to save face. The P-38 was never a cheap fighter, but the introduction of this official solution cost tens of millions in research and installation money spent only to avoid the embarrassment of crediting the genius of the shop floor. Reilly's 1/8-inch cable cost $5. Arrogance cost the nation millions, and cost Reilly all credit. But in the field, the truth was known. Reilly's modification became tribal knowledge, a sacred secret. It was passed down from veteran to rookie, from mechanic to mechanic. Every new P-38 arriving in the theater was pulled aside, dismantled in secret, and quietly modded before its first combat flight. The pilots knew. The mechanics knew. Only the formal historical record remained intentionally ignorant. The improved performance was instead attributed to generalized factors. Generals cited superior combat tactics, improved pilot training, or minor, official aerodynamic tweaks. The engineering flaw, the threat of the compressibility shock, was officially swept under the rug of wartime necessity. The P-38 Lightning, a plane once doomed by its own speed, became the bane of the Zero, but only because of that uncredited modification. This is the dark, uncomfortable truth of wartime innovation. The most decisive tactical shift in the Pacific Aerial War was secured not by the official budget, but by a corporal's simple ingenuity. And what of the mechanic, Corporal James Reilly? He finished his tour. He never received a Distinguished Service Medal, a commendation for bravery, or even a letter of thanks. His work was too simple, too disruptive, and too damning of the established hierarchy to be acknowledged. His name was diligently swept from official modification reports. He returned home to the anonymity of civilian life, perhaps to fix cars or machinery. His legacy was an undocumented footnote, secured only in the logbooks of the pilots whose lives he saved, and in the quiet certainty of the ground crews who kept the secret. He was the hidden ace of the Pacific, the man who used a piece of wire and intuition to defeat a law of aerodynamics. The war was won by those who refused to accept the word impossible. And the stories of hidden engineering and practical genius are the ones that truly reveal how the fate of nations is decided on the floor of a dusty workshop. We have just witnessed one of the most compelling and frustrating stories of World War II. The P-38 Lightning was a testament to American technological ambition, yet it was crippled by a technical oversight so fundamental that only the simplest of solutions could fix it. But the real lesson here is not about the plane. It's about the hierarchy. It's about how brilliant, life-saving innovation was nearly killed by the fear of bureaucratic embarrassment. The Corporal James Reilly mod remains the perfect symbol of how the true genius often lies outside the boardroom, hidden in the oil and grease of the hangar floor. His story reminds us, when science clashes with rigid systems, the simple, practical truth will always prevail. but often without recognition. If this deep dive into the technical details, the personal risk, and the sheer audacity of Corporal Reilly's stupid wire trick resonated with you, show your support now. Take a quick moment to hit the like button on this video, and most importantly, subscribe to the channel. We are dedicated to unearthing these hidden engineering stories, the quiet, uncredited acts that genuinely change the course of history. Use the comments below to tell us what other overlooked technical heroics have been erased from the official record. Your engagement allows us to continue our mission. Next time, we journey to the skies over Europe to investigate another hidden technological war. We will look at the German Fugue 200 radar system, a masterpiece of frequency modulation that rendered the early Allied bombing raids completely ineffective. It was a technological lead so dominant, it almost won the air war for the Axis. How did the Allies break this nearly invisible electronic wall? Not with a massive counter-radar system, but with another brilliant, uncredited modification made by an unknown technician in the dark. It is a story of codes, frequencies, and a simple switch that turned the tide. Click on the video thumbnail you see on your screen now to watch our next story, The Quiet Genius Who Broke the FUG 200 Radar. Until then, keep questioning the official story and never forget the mechanics who saved the war.